When I ended my last segment, I suggested you try the next two problems, and here's the first. When I ended my last segment, I suggested you try the next two problems, and here's the first. There is one dilemma with the next two problems, and that is that the unknown that we're going to be solving for is going to lie in the denominator, and that makes this problem a little bit harder. So remember, you should draw a picture of your situation. Call angle C the right angle, the hypotenuse, lowercase c. I drew a picture here, and angle A is 74 degrees, so it sure looks like I should put angle A here because 74.2 degrees looks like about the size of this angle. Therefore, this is side A. This would be angle B, and this would be side B, therefore. Please come on over here. Fill in a table. I just think it's a really good habit to get into to help you keep track of your data, what you were given. So we're given 1.849 for side A, and we're given 74.2 degrees for angle A. Remember, angle C is 90 degrees. I tend to put a little check mark by the things that I was given. So again, this is still the case 1 scenario. So to find angle B, I'm going to take 90 degrees and subtract the 74.2, and I'm going to get 15.8 degrees. I just noticed that I'm doing problem number 3 instead of problem number 2. It doesn't matter. I'll back up and do that one in a minute. They're both very similar. So I've got angle B. Now, which trig functions do I use to find side B and side C? Do I use sine, cosine, or tangent? I only need to find two things. So I only need to use two of these to find those values. Remember, highlight what you were given. Side A is equal to 1.849. So kind of important to me to keep track of what I was given in the form of my picture. If you struggle, should I use sine? Should I use cosine? Should I use tangent? Go ahead and write them all down in terms of letters. So go ahead and write down that the sine of A is equal to the side opposite over the hypotenuse. The cosine of angle A is equal to the side adjacent to it over the hypotenuse. And the tangent of angle A is equal to the side opposite over the side adjacent. And now, with these three statements, highlight the things you know. You know angle A for every one of them. And you know side A. There's no A here. You know side A. So I wouldn't use cosine to solve this problem, because there's B and C that I don't know. But if I use sine, I can solve for side C. And if I can use tangent, I can solve for side B. So I'm going to do that now. I'm going to take this over here, and I'm going to put in the numbers. And I'm going to say that the sine of angle A, so put in the number for angle A, equals side A divided by side C. Most people would solve this algebraically by noticing that C is downstairs, and they would multiply both sides by C to get it upstairs, and the C's cancel over here. So now what you have on the left side is C times the sine of 74.2 degrees equals the 1.849. That's all you have. You want to solve for C, so you're going to divide by the sine of 74.2 degrees, both sides, in order to solve for C. So in this problem, when my unknown was downstairs, I'm going to do division. In the previous problem, I did multiplication. I'm going to snag my calculator. Okay, I need to type 1.849 divided by the sine of 74.2. And that will give me my solution for side C. So side C right here is 1.922, I think I'm going to call it. See this 4 significant digits? I'm going to call it 1.922. I'm going to round to that spot right there. 1.922. So side C is 1.922. I'm also going to go fill it in on my table. And I just want to show you some algebra here. I'm going to cross those off. That's how I got side C, by dividing both sides by the sine of 74. All right. Let's do this again now with tangent. And so I have the tangent of angle A, which is the tangent of 74.2 degrees equals side A over side C. Do you see right here? Oh, I'm sorry, it's side B for tangent. It's right here, side B. Do you see right here when we did this calculation, our unknown was in the denominator as well. I don't need to show the algebra every time, like here, multiplying both sides by B. I can look at the pattern over here, and to solve for C, I took this numerator, the 1.849, and divided it by the sine of 74. See the sine 74? So I often call this an algebra switcheroo. I move that B over here, I move that tangent 74.2 down there, and I don't have to show my algebra then every time because it's just repetitive. It's the same thing every time. So when my unknown is downstairs, I move it over here, I move that down there, and then I've done all my algebra. So now I'm going to type this on my calculator. So I'm going to take 1.849 and divide it by the tangent of 74.2 degrees. And I'm going to find out that side B is 0.523. 0.523. So side B was equal to 0.523. And now I'm all done, but I'm going to check. And what I tend to do is when I'm given just one side, I check using the Pythagorean theorem. So actually, I'm going to use this number and this number in the Pythagorean theorem so I can use two legs and see if the hypotenuse is 1.922. That way I can know if I did the problem correctly. So I'm going to go ahead here. Again, I don't have the program. So I'm going to go second square root. So I'm taking the square root of the square of the sum of the square of these sides. 0.523 squared, close the parentheses, and I want to see if it's 1.922. Close enough. I know I did this problem right because I calculated these two and put into the Pythagorean theorem. It gave me this hypotenuse. Real happy with the fact that I can check these. All right, let's do it again. Let's just do it a little bit faster. All right, so going up to number 2. So angle A, angle B, angle C. And we won't show as much work from now on. So angle B is 64.3 degrees, side B is 0.652, and angle C is 90 degrees. So those three things were my givens. I'm also going to label my picture. So angle C, side C. Oh look, 64 degrees. It looks as though I tried to draw this as 64 degrees. So I'm going to call this angle B. 64.3 degrees. And this will be side B, and it was given, and it's 0.652. Here's angle A, and here's side A. Again, I was given side B, I was given angle B. So I'm going to focus on writing here the tangent of angle B, the cosine of angle B. I'm sorry, I said tangent. Sine of angle B, cosine of angle B, tangent of angle B. I'm going to focus on angle B. However, before I go there, I'm just going to use red for this. Before I go there, I'm going to find the size of angle A by taking 90 degrees and subtracting the 64.3 degrees. And that gives me 25.7 degrees for angle A. Good enough. All right, let's try to do finding side A and side C without writing all three trig functions. Let's go for side A first, and let's see if we're going to use sine, cosine, or tangent. So if I'm using this angle, and I want to find A, and I was given B. For angle B, this is called the side opposite. This is called the side adjacent. Again, for this angle, I'm going to use the side I was given, opposite, and I want to find the adjacent. Which of these uses opposite and adjacent? Oh, just that one. Uses opposite and adjacent. So I would write that the tangent of angle B equals this, the tangent of 64.3 degrees equals the side opposite over the side adjacent. So go ahead and put the numbers in right away. Don't put letters down. You know that that's the side opposite, that's the side adjacent. Do our switcheroo. Move A up here. Move this down here. When the unknown is downstairs, it's going to be a division problem. It's going to be 0.652 divided by the tangent of 64.3 degrees. Let's find out what that is. Figures I'm a little bit unable to see. Let's see if I can do it this way. Well, I'll try it. 0.652 divided by the tangent of 64.3 degrees. And that should be side A, 0.314. Let's see, that would be the number of places I should probably write this to, 0.314. 0.314 is side A. All right, let's go back to our picture. So I just found this one. Now I want to find C. That's the only thing that's left here. So I was given the opposite side. I want to find the hypotenuse. Again, say it again. With regards to the angle I was given the opposite side and I want the hypotenuse. Which of these three uses opposite and hypotenuse? Oh, that's sine. So the sine, I'll even write it in letters this time. The sine of angle B equals the side opposite over the hypotenuse. So again, I was given this, I was given this. I can find side C. Move this over here. So you would find side C by taking little b and dividing it by the sine of angle B. So for us, that's going to be 0.652 divided by the sine of 64.3 degrees. And if you do that, side C will be equal to 0.742. And don't forget, if you put these two into the Pythagorean theorem, squared them, added them together, take the square root, you would get this